All right, so this is extended response question 3. This is a quadratics problem, and because it's extended response, I highly recommend that you use your CAS calculator. And if you do, then it's a really quick and easy question to do. So here we go. A ball is thrown upwards and its height above the ground, h meters, can be found at any point in time from the following equation. What I can see there is they've given us a quadratic equation because I can see if I expanded the brackets t times t is going to give me t squared. But notice it's a negative t times t, so it's likely going to be a negative t squared, meaning it's going to be a negative parabolic shape. With my years of experience, I guess when I look at it, I can already tell x-intercept is going to be at t equals 5, and this one is going to be t equals negative 1. So in my mind already, I've got negative 1 and then 5. Those are my intercepts. And then it's a frown parabolic shape, so it's going to look something like that. Okay, so in my mind, that's what I'm seeing, but how did I know those were the intercepts? Well, there's a couple of things here. You can do it by hand. You can say, well, because the first question says sketch the graph, right? You got h, you got t. Well, to find the x-intercepts, which is technically t-intercepts, it's when y equals 0, or in this case, it's when h equals 0. So if you do it manually, you can see, well, if h was to equal to 0, you get a quarter times 5 minus t, bracket t minus 1. And when you use null factor law, because this is already factorized for you, null factor law says that if you multiply factors and it equals 0, which currently it equals 0, you got a quarter multiplied to 5 minus t times t minus 1, right? Well, t minus 1. So out of these factors here, you see a quarter times something has to equal 0. The logic is that one of these, it's either 5 minus t or t minus 1 has to equal to 0. Because clearly it's not a quarter. A quarter can't make it 0. So by that theory, we can say, well, maybe 5 minus t was meant to equal to 0. Because if it was 0, then 0 times anything will make it 0. So using null factor law here, I can already see 5 minus t, solve for it, add t on both sides, and 5 equals to t. That's how I knew t could equal to 5. And then same thing over here, you could have worked it out. T minus 1 is equal to 0, add 1 on both sides, and t could equal to 1. Whoops, did I do that wrong before? Oh, it's plus 1. Whoops, plus 1, plus 1. So therefore, should be minus 1 on both sides, okay? And that's how I knew that you could have an intercept at negative 1 for t, and when t equals 5, you should have negative 1, h will be 0, and this is 5, h will be 0. So t equals 5, h is 0, t equals negative 1, h is 0. Okay? And then the whole frown thing, well, that's me just expanding the brackets. But again, this is me doing it by hand. Okay, so this is covering it by hand. I would have recommended that you should have done it on a CAS. So in fact, this is probably what you should have done from the beginning. What you should have done instead is right here, you do what I taught in class. I say menu, define it. So menu actions. So number 1, and then go to define, which is number 1 again. So menu 1, 1. You define a function. So you go f bracket. So there's a bracket down where the 0 is. Press X, close brackets, is equal to, and then you type in the equation they gave you. So control divide 1 over 4. Whoops. 1 over 4. Times 5 minus, now I know it's meant to be t, but because you were going to sketch it on the axes in your calculator, they only sketch x. So I'm going to change it to x, okay? And then the other one was times by t plus, what was it? X plus 1, I think it was, t plus 1, yeah. All right, and I press enter. All right, so I've defined it, okay? And you'll see the benefit of defining it because then answering the next few questions will be much quicker. So from here, if I want to sketch it and have a look at what the graph looks like, I'm going to go Control, Doc, so add a page. Why didn't that work? Add a page. And I'm going to add on a graph, so number 2. And because I've defined it once already, I can just type f bracket x, close brackets, and there's my graph. But logically, you can find the x-intercepts through, I already know it's negative 1 and 5, but we can test it by going Menu, Analyze, number 6, and go to 0, which is number 1, And because I know the x-intercept is somewhere here, I just go to the left of where I think it is, click once, go to the right of the intercept and click once again. And you can see it's clearly at -1, 0. And I do the same for this side over here. I go menu, 6, and then number 1. And I can tell the x-intercept is somewhere here, so I'll go to the left of it, click once, go to the right of it, click once, and there we go. We've got -150. Okay, and then lastly, well, I need to find turning point and y-intercept, all of which you can do very quickly through the CAS, or well, turning point you can do quickly. So menu, analyze, let's find the turning point. It's a maximum type of graph, so maximum. So I'm going to go left of where the turning point is. So turning point is roughly here. I'm going to go to the left of it, click once, go to the right of it, click once, and there's my turning point. It's at 2 when t equals 2. Height is going to be 2.25. And the y-intercept, you can do it. There's a long way of doing it through the graph sections. I normally just go back to this section here. And how you go back is you do control, and there's that left arrow. You can click left arrow and you turn back to this previous page. You know that the y-intercept occurs when x equals 0. So you can actually replace the letter x with 0. If you type f, open brackets, 0, close brackets, there you go. It's effectively the same thing as you substituting 0 into the equation and then evaluating it yourself. The calculator does it for you. So I already know now from this that the y-intercept has to be at 5/4. So I now know it's at 5/4, which is really 1.25. Okay, when x is 0, when x is 0, it's 1.25. And we already got the maximum at 2.25. There you go. Now, if you did draw this type of graph and you've labeled all the key points, fantastic, but you will still lose a point. And the reason why is because this is an application. This is now extended response questions. You've got to think about, well, what are the actual real possibilities? You see, when t represents time. When you're talking about time can never be negative. So this whole region on the left-hand side here shouldn't even exist. How can I have t equals -1? That's not even possible. So that means everything on this side should not be sketched. So that means I shouldn't be including any of that. Okay, so the graph should actually only start when t is equal to 0, okay, which is right at this point. So when t equals 0, we've got a height of 1.25 or 514. Yeah? And it goes up, and then it goes all the way down. But then logically, again, can you have a height? If you're throwing a ball up into the air, once it lands on the ground, that's where 0 is. It doesn't make sense to fall through the ground. I mean, unless somehow it can burn through the ground, then in this case here, you are only meant to sketch up until h equals 0. So your graph should have only started at this point, goes up, comes back down, and finishes right here, and that should have been at 5:0. Label your turning point. So at 2 seconds, it's at its highest point, which is 2.25 meters. And at the very beginning, when time is 0, then it started off at 1.25 meters above the ground. Okay, so you should have a graph something like that, and that's what they did here. Okay, so these are the solutions, and you can see they've got 1.25, 50, and then 2. That looks like 2025, but it's actually 2.25. Okay, so there you go. That's how you sketch it. And let's go to the next few questions here. It says, from what height is the ball initially thrown? Initially just means when time equals 0, and we've already solved it accidentally before. I had solved it before. I wrote f of 0, and we had 1.25 or 514. All right, so it starts off initially looking at the graph. Clearly, it starts off at 1.25 meters or 514 meters above the ground. How long is the ball in the air for? Well, it looks like it was in the air from the beginning, t equals 0, all the way up until it landed on the ground at h equals 0. So that's 5 seconds. So we can tell it's 5 seconds out in the air just based on the graph. And then lastly, what is the maximum height the ball reaches? Well, maximum height, clearly this is t. So after 2 seconds, 2 seconds, it reaches a maximum height of 2.25 meters. So this is my height. It doesn't actually get any higher than 2.25 and then drops back down. You see that? So the height gets a maximum of 2.25 and then it starts to drop down until it hits 0 again. So the answer here would then be 2.25 meters. And that's how they did it over here. But each one, again, make sure to have your units, make sure to draw the graph with all its labeling. And I guess the common mistake was not to take into account that you can't have negative time and you can't have negative height in this scenario anyway. Okay, and that hopefully answers question 3, but it's all CAS work. You literally just work with your CAS and should take a couple of seconds to do. Okay, so this question could have been done in about a minute to 2, and if you labeled all the key features, answering the question was very direct and quick. Okay.